Right? So number one is an external force. If it feels like this chapter is a little bit repetitive, and it's because it is, okay? It's a lot of the same words and things over and over again. Chapter 6, chapter 7, it just all keeps going together. 2 is the definition of the system, which is kind of like a fancy way of saying, I guess, like the physicist on scene would decide that. So yesterday I said, for example, I told a story about me in my car with my foot on the gas and also friction, like balancing out my gas pedal force. All of that stuff was part of my system. So all of those forces would have been internal or external. A theory, 50-50 guess. All of that stuff, the gas pedal, the friction, would those be internal or external forces if I frame the question that way? Internal, because they're part of my system that I defined. Then something like a truck that appears out of nowhere and hits me, that would be external, because that wasn't what I originally had discussed. If I only had discussed me in my car and framed the question that way, now friction would be external, because I didn't include that when I framed the question, when I originated the question. So there's some sort of a physicist in charge, I guess, at the scene, if you want to look at it that way, and they get to decide whether that force is internal or external when they like set up the question of, this is part of our scene, anything that's part of the scene is internal, and anything new that appears after you've set the stage, that's external. Okay, so that's up to somebody to come up with some sort of definition at the beginning of who's part of what. So the definition of the system, whenever it is like created by the physicist, that determines whether you're internal or external. 3 is constant or unchanging, and then we just start hitting a bunch of old words again. So momentum's mass and velocity, vector quantity changes when velocity changes. Let's see, that answer, we were doing unbalanced forces for 7, force and time is 8, change in momentum is 9. For a moment I hesitated on 7 to look at my other paper, just because I know there's a sentence that an impulse causes a change in momentum. Okay, we used that sentence on 9. So you can't use the same sentence on 7. We need to do a different sentence. And on 9 I painted us into a corner. Impulse produces. You have nowhere to go but change in momentum. So to vary that back on 7, back there you'd have to talk unbalanced force. So, but there are 2 basic sentences that are almost the same. 10, we have Ft equals m delta v. 11 is law of action and reaction. Stating that every force is accompanied by an equal and opposite force. I'm pretty sure on the test I'm going to want an example of that, and we did a few of those yesterday. What that leads to is law of conservation of momentum, which is total momentum of an isolated system cannot change. If we're short the total momentum, we'll go half today, but that's like a full point kind of issue probably tomorrow. Isolated system is an important word to have isolated in there. I could do that as like a half point kind of word. So if all they said is momentum doesn't change, they didn't score, because we're short the isolated system, we're short the total. But if they get some of those other words in there, maybe they're a half, maybe they're a whole. Equation for it, m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. So isolated system, there's no outside forces acting on it. And in 7, it would gain the momentum lost by the other. Gains the momentum lost by the other. Okay, tomorrow quiz, we nudge up a point to 18 points. Reading 7.5, and the chapter will end at that point. So 1 new point of reading. And then it looks like everything else just stays the way it is. The only thing that might deceive you is the order. I didn't do what I normally do with the order where the top goes to the bottom and everything stays in the exact same order. That's not the way it went. But the questions are all here. So 17 points, one new one at the top, but don't just start filling in the order that you would expect because it's not the order that they're going to be in. Homeworky work off of this, we're going 14 to 20. There's not a new equation, we're still using yesterday's equation. I wouldn't rule out that the FT equals M delta V appears. I don't know, I didn't look at the homework super carefully. Maybe that comes back too, but it's more of yesterday's equation. What do I mean by yesterday's equation? M1B1, that thing. Okay, so we're going to have an equals. Before the equals is going to be stuff that was happening before the boom, before the collision. After the equals, we're going to do for stuff that's happening after the boom, or after the collision. So here's our story. We have a 40 kilogram object that's being shot from a 2,000 kilogram launcher. Like you've got a big old cannon that's 2,000 kilograms, and we're shooting a 40 kilogram object out of it. What we're trying to do is figure out the recoil velocity, because like yesterday, talking about the Newton's laws, if we shoot something forward, the shooter is going to go backwards, okay? Because every force is accompanied by an equal and opposite force. You would expect the smaller object to be shot and go pretty far, and also go pretty fast. You'd expect the giant cannon to go not as far and slower. Okay. That would be a pretty ridiculous situation if the bullet and the gun went the same speed. Like that. That's not what you're after. You're not after the bullet and the gun going the same distance. Like that wouldn't be good for finding your gun later. Boom, the bullet's a mile away and so is the gun. Not going to be a good way to play that game, as it like rips your arm out or something. But anyway, before the big boom, what's the momentum before the big boom? Zero is correct. Because if you're shooting a cannon, before you shoot it, everything is still at rest. At rest means it has a velocity of zero. So if you have zero momentum, or zero velocity, that means you have a momentum of zero. So before the big boom, the momentum is zero. How about after the big boom? How would you do some momentum moves? Like M1, 40. Its velocity is 100 plus 2,000, and there's an X. So before the big boom, we had no momentum because nothing was moving, had no velocity, just goes zero equals. Any of these launcher problems, it's always going to be zero equals, because you're never going to launch something from a moving gun in these problems anyway. It's not, I mean, I guess you could if you were in the military, like you're driving your tank and you shoot stuff out of it. I guess it could have momentum at the beginning, but these, it's all going to be stationary stuff being shot, so they're all going to go zero equals. One times another plus one times another. There can only be one unknown to make it algebra possible. So how do we now algebra solve this? Multiply these, that'll be 4,000. Then subtract that 4,000 out of there. Divide by the 2,000. And our answer? -2. If we wanted to practice our digits, 0.00 unit on this, meters per second. Does that make sense based on the conversation that we had at the beginning? Yes. Why? What makes sense about it? Okay, if one of them's going forward, the other one has to go backward. How did that manifest itself in our answer that something's going backward? It's negative. So if this had a positive velocity to go forward, this better have a negative velocity to go backward. What else makes sense about the 2 in its size? It's smaller. Okay, so the little thing had a high speed. The big thing we'd expect to have a much lower speed. In fact, if you experience these problems a few times, we didn't actually need the equation here. This was 50 times bigger. So if you have one thing go 50 times bigger, the other thing is going to go 50 times faster or slower, depending on your point of view. So since this was a times 50 kind of thing, these also need to be a times 50 kind of thing. That's not an accident. That's got to happen. What if these were the same mass? They'd be the same speeds. Just one of them would be negative and one positive. That's the kind of problems you'll do tonight. They'll probably be 0 equals. Something's got to be positive, something's got to be negative. 14 to 20, question about that part of life. Okay, if you didn't do the 1 to 7 yet, do that soon, get that to me. Let's look at the 8 to 13. We'll get to 8 to 13 in just a minute here. Anybody have confidence in your answer to 8? 18. It is not. It is 22. So 8, we're hoping for 22. Somebody other than the voice who gave us 22, what do you think about 10A?
6.5.
Disagree with 6.5. I agree with 11.5. Let's do, did we say a unit on 8? It is centimeters per second to match what they did. 8A's unit? Meters per second. For B and C, what should be a, I don't know if I'd say interesting, I don't know if it's actually interesting in the grand scheme of things, but a noticeable thing that should happen in the 8B answer compared to the 8C answer. They should be almost the same. Why do I say almost the same instead of saying they are completely the same? They're very nearly the same. Let's think of the quiz. When we're dealing with momentum, one object gains the momentum, lost by the other. How would that manifest itself in the answers to B and C that makes me say they're almost the same? If one object gained and the other object lost. Okay, so how would that manifest itself on these numbers? One's negative, one's positive. So let's get the number first. For BC, they should share the same number. What number would they share? Somebody other than Alyssa and Raina, who already played with us. Anybody for B and C have a number? 40. It is 40. Let's do a unit on B and C for momentum. Newton seconds. And when I say Newton seconds, it looks like Newton's multiplying seconds. I don't say the multiplying when I say it. I just read that, Newton seconds. And then let's decide which one is the negative one. It is B, because the first glider did what in the real world to make its change in momentum a negative? How do you have a negative change in momentum?
Lost.
Yeah. How would that show up in the real world? How could we see that a thing has less momentum?
Like slow down.
Slow down. Okay, so the first glider slowed down. That had a negative momentum change. The other one had a positive momentum change for C because that's the one that sped up. So if it gains momentum, that's a positive change. If it loses momentum, that's a negative change. 12, there's an issue with them being a little bit tricky about how they posed the question. You had to notice and fix a detail before you could start C, or before you could start 12. There's a detail that must be noticed. What about the masses?
You did. The grams.
Yeah. change one of the kilograms or grams. So if you like grams, change the kilograms. If you like kilograms, change the grams. It really doesn't matter which one you change. You just have to make sure that they match in unit. Okay, so kilo, what's the magic number for kilo? 1,000. So if you want to change the 5 kilo to grams, the 5 could become 5,000. Because if it's 5 kilo, it's 5,000. Kilo means 1,000. If you want to change the other one, what would 50 grams become if you change that one? Disagree? Since 1,000 has 3 zeros, what's the quick cheat on this? How can you take 50 and change it in a conversion that involved 3 zeros? Move what left? The decimal. Find the decimal point, move it left 3 spots because of the 3 zeros in 1,000 from kilo. So if you do that to the 50, what could you make the 50? 0.05. Doesn't matter which one you change, and you don't have to change them both. You just have to change either of them. So either the 50 is a 0.05, or the 5 is a 5,000, and then go at it. Anybody 12 that made that change that has potentially an answer?
10.001.
Disagree. We'll let people puzzle that out for a bit. I'm not going to tell you, you tell me eventually. We still have like 15 minutes for a room of smart people to work on that and somebody figure it out. Anybody need help other than 12 while we're trying to get somebody to go get me 12? 9. So 9, you'd want to take the 10 times a 20 plus a 20 times a 10, then it equals the 10 times an 8. The first ball, the 10, is moving at the 8, plus the 20 would have the x. We changed what you had there, right? Does that make a difference?
Yeah.
Okay, so now solve the new one. Anybody else, something to help you out? Yep. 10. Okay, so 10, we would do the 5 times the 15 plus the 10 times 7.5, then it equals back to the 5 times 7 plus a 15 times x or something. And then we want to solve that.
Yeah, I have A, but I can't do this.
Okay, so then to do B, what we would do is just the 5 times 15 part. Then skip after the equals and just do the 5 times 7 part. And figure out what that change was. So 5 times 15 is 75 from before the collision. 5 times 7 is 35 from after the collision. So the change there, if you subtract, is 40. It's a negative change because it went down. You okay on that? And then I would not do math on C, I would do knowledge of the universe. If the one is losing 40, or the other gains 40. Other stuff other than 12. Can anybody get me 12 now after that brief intermission?
Is it 1,010?
It is 1,010. Let's throw a unit on there.
Meters per second.
I agree with that. 1,010 meters per second. That's one of the problems where they combined and locked. Like, before they collided, there was a bullet and there was a block. And after they collided, there was a bullet block. Like, the bullet was embedded in the block. There's no longer two items, there's now just one item to deal with. Anybody need more advice about anything, including how we arrived at the answer for 12, now that we have an answer? Okay, how do you have yours set?
50 plus 5,000 times 10.
Okay, we want to go 50 times its original speed. What was 50's original speed?
Is it 10 with the 50?
No. What was the 50's original speed? No. What is the 50?
The bullet?
It's the bullet. What's the bullet's original speed?
X.
X, because
We don't know.
we don't know it, that's what we see. So we're gonna go 50 times X, but it sort of stands to reason the bullet is probably going really
Yeah.
fast. That's how bullets work, they go fast. So we're gonna go 50 times the X plus the block, 5,000 if you changed it that way. What's the original speed of the block that you're shooting? Disagree. 0. The block was just sitting there minding its own business. The block was at rest. So 50 times X, which is fast, plus 5,000 times 0, because the block wasn't going anywhere at first, equals, after the bullet becomes embedded in the block, what's the mass of the bullet block? 5,050. What's the speed of the bullet block after the bullet has smacked the block? That's the 10 finally. So 50 times X plus 5,000 times 0 equals 5,050 times the 10, and now math it. Does that make sense?
Yeah.
You just have to be real careful on these. You get the right velocity with the right partner. That's like the biggest issue, is make sure the right velocity is with the right mass by just a careful read and react. Anybody else? 8 to 13, anything I can do to improve the quality of your 8 to 13 performances?
11.
11. So we're gonna go 700 times 20 plus 1,400 times 0, because that car was just, it was stationary, means at rest. Then it equals. After the equals, do you still have two different cars, or do you have one mass of junk?
One mass.
Okay, one mass. What's your new one mass?
21,000.
2,100. And then the speed of that mess,
No, X.
that's the X. Is that enough?
Yeah. Thank you.
Yep. Anything else I can do? Yep.
50.
Which team? 13? I guess, yeah, that is the only team, isn't it? So 13, we're gonna go unknown mass, so there's our X, times 40, plus, okay, we have a second ball, 150 times 15, then the equals, because we got to the collision. As soon as it starts mentioning the collision, throw the equals. They mentioned the first ball. What was the mass of the first ball? Disagree. Say again? X. So we're going to go X again, but this time times, I think I heard it, 20, plus second ball, 150 times 42. So that looks like, again, X times 40 plus 150 times 15 equals X again, because we still don't know what the mass of that ball was, X times 20 plus 150 again times 42. Is that okay? Then you're going to have to do a little something on this the other ones didn't have. You're going to have to get all the X's to a side. So all the X's go to one side, all the numbers go to the other side, and that solves a little differently than the other ones, because that's the first one that had that X twice. Other stuff on 8 to 13, quality control improvements. So make sure names are on there, label that as like 8 to 13. If you have a 1 to 7, throw that in the mix, but label it that it's 1 to 7. We'll shoot those toward the aisle and I'll grab them. Again, next time we're 7-5 read, that's the last read of the chapter, one new point, everything else is the same. Homework problems have to do with like sort of cannon shooting and recoil velocities. That's going from 14 to 12.
Okay,